Everything's funny to me. Yeah. All right, so this one, we have to write the equilibrium constant expression. We try with the whiteboard. Let's try that. We'll see how it goes. Okay, I'm just going to change my marker really quick. So do you remember how to write an equilibrium expression? You don't know? Okay, we'll do it together. That's annoying. Okay, so remember we have our equilibrium expression is products. Do you remember this? Over the concentration of the products over the concentration of the reactants. And then if there's any coefficients, we raise it to the coefficient. So this one we have our product is H2 and Cl2. So KEQ is, and then this one is, are they gases? Are all gases, so then we don't need the concentration, we use the pressures. So this is Cl2 with no exponent because there's just a 1 times H2, no coefficient because it's just a 1. So products over the reactant is HCl, and that's raised to the 2 coefficient because there's a 2 in the front of the HCl. So then all we have to do is we have to plug in the numbers. So we look at this table and it says that Cl is 0.85. So instead of writing Cl, I'm going to put 0.85. Instead of H2, I'm going to put 0.98. Instead of HCl, I'm going to put 1.4, and I have to square that. Okay, does that make sense? Do you see where that came from? Okay, and then I just type that in to my Alex calculator or your personal calculator. Can't use your phone on the test as a calculator. Oh, it's not coming on. There we go. There's our calculator. So then we're going to type in here 0.85 times 0.98, and then all divided by, we'll put it in. All divided by 1.4 squared. And then your calculator equals. Okay, this has 3 sig figs. So we look back at our numbers. This one has 2, this one has 2, this one has 2. Let's just check. Does it have 2? Okay, so this should have 2 because everything else has 2. So we'll round to 0.43. Okay, does that make sense? So we're just replacing the values in our equilibrium expression with the values that are there. Okay, any questions on that one? Do you want to do another one like this? Okay, let's do another one. Let me erase the notes. Okay, so this one, is this the same one? Oh no. Okay, great. This one has lots of values. So we're going to put the concentration of the products on the top over the concentration of the reactants. This is actually pressure, so we don't need concentrations. So equilibrium is products. So we've got water to the squared times by chlorine gas, squared, because there's a 2 in the front, all over HCl gas to the 4th power times by oxygen gas to the no power, because there's just a 1. Just a 1 power, I guess, not a no power. And then I just put the values from the table where my equation, in the equation. So I need water. Water is 7 be 4.3 atmospheres, square that, times by 8.83, also squared, over HCl, which is 55.1, to the 4th power, times by oxygen, which is 16.9. Okay, and then I just find my Alex calculator and type those numbers in. So let me put this in parentheses. So I've got 74.3, and that's going to be squared. And then times by 8.83 squared. Oh. Oops. I meant to put my parentheses around the whole top. There we go. And then this I'm going to divide by 55.1 to the 4 times by, oops, not the exponent, times by this, times by 16.9. And then I have this number. I'm probably going to need 3 sig figs. Let's check. See what the homework tells me. Oh, this still says 2. Okay, so this one might be one that they tell you what to round it to on the test, because 2 is different than all the numbers that we have. So I'm going to put it in scientific notation with my Alex calculator. So I'm just using this button. And if I round to 2, then that's going to be 2.8. 2.8 times 10. Oh, is it? I forgot. 2.8 times 2.8. Oh, it's 9. Times 10 to the minus 3. Okay. We got that one? Okay, so that's pretty easy. We already learned this, and you just plug the numbers in. Okay, let's figure out the next one. What's the next one? Recognizing equilibrium from a sketch. Okay, this one is pretty straightforward. Oh. Here it is. I'm trying to put it in this little spot on my. We'll just switch sides. Okay, so this is a picture of our what is it a picture of? Our reaction. Okay, so we have this little microscopic window we're looking at these reactants. And we have this over here. This is telling us that this is a reactant, the red thing is a reactant, and the blue thing is a product. So when we write our equilibrium expression, we need our products over our reactants. And here our product is the blue thing. And here our red thing is the reactant. Okay, so what we need to do is we need to count up how many blue things there are. 1, 2, 3, 4, 5, 6, 7. So I count 7 blue things. 7 blue. And I see 1, 2, 3 red things. Do you agree with that? Okay, so then on this one, if it's at equilibrium, the ratio will be 7/3. Is that true? That's true, so it's at equilibrium. So this one is yes, it's at equilibrium. Okay, so this one basically you just need to know products over reactants is the equation for equilibrium. So how about this one? This one says we have the pink thing. So pink over yellow. And that should equal 1/5 if it's at equilibrium. So I'm going to count the pink ones. 1, 2, I have 2 pink ones. I have 2, 4, 6, 8. Is that right? 2, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 yellow ones. So this simplifies to 1 over 4. So is this equal? That's not equal, so it's not at equilibrium. Not at equilibrium. So then I just put no. So it's not too bad. You just have to remember a few key things. So products go on top, reactants over on the bottom, and then just see if your ratio matches the equilibrium constant. So this one's gray over blue, products over reactants. The gray, I have 4 gray ones. There's 1, 2, 3, 4, 5, 6, 7, 8 blue. You agree with that? So on the test, I would double check these. Just I'm not very consistent in counting, so that's something that I would check. Okay, and then if I simplify this, this is 1 over 2. So that does not equal the equilibrium expression that they gave me. So at equilibrium, this would be the ratio. So this is not at equilibrium. Does that make sense? Okay, let's do one more of these. So the last one says yellow over green. There are 5 yellows and 1, 2, 3, 4, 5, 6, 7 green ones. And our equilibrium expression should be 5 over 7 if it's at equilibrium. That's true. So this one is at equilibrium. Yes, that matches. Does that make sense? Okay. All right. If it simplifies and it matches, it's fine too. Okay. Let's do the last topic. The last one is predicting equilibrium composition from a sketch. Okay, this one is hard for me because it's dealing with fractions, and I have a hard time with fractions. But it's also not too bad. So let's go for a few of these ones. So still same thing, we need to remember that it's products over reactants. So products over reactants is the equilibrium expression. Okay, and we have this picture. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 molecules. So keep that in mind. Total 10. So we can't change the number of molecules. We're stuck. We're locked into having 10. And so products over reactants. This one we would have product pink over yellow. So right now we have 5 pink ones, 1, 2, 3, 4, 5 pink, and 1, 2, 3, 4, 5 yellow. So right now the equilibrium, or it's called the reaction coefficient, is 1. We have 5 products to 5 reactants, so it's not at equilibrium yet. So it's telling me that these can interconvert. If I have this ratio, it's at equilibrium, 3 over 2. So we need to figure out how many of these yellow ones need to move up to get to be a product, to be pink, to have this equilibrium expression equal to 3 over 2. So if we move, so some of you can probably just figure this out. If you can't figure it out, this is kind of how I do it. I say, well, what if I move 1 up here? So I'm going to move 1 up there. Now I'm going to have 6 over 4. Right? So I just took one of the reactants and I put it as a product. So now let's see, what does that simplify to? Well, luckily, that we just did one step. That simplifies. So sometimes I have to do this like 4 times until I get it to simplify. But basically what you did is you just shuffled the yellow into being the pink. If you can just see that without shuffling them, if you can figure out the ratio, like, oh, 6 plus 4 is 10. 6 plus 4 is 10. 6 over 4 gives me 3 over 2. So that's kind of what we're doing. But you can't change, you have to have 10 total molecules. Okay, this is also kind of annoying that we've been using products over reactants, and then they switched the answer box. The answer box has reactants on the top and products on the bottom. So this is my reactants, so that's 2. And my products are 3. Oh, but not that. How many? This is the ratio, the simplified. We need 6 and 4. So we have 4 reactant molecules in this picture, and we'll have 6 product molecules in this picture for this to be at equilibrium. Does that make sense? Okay. So not too bad, just like, I just have a hard time with fractions sometimes. Oh, let's do another one of those. Okay, so we have this picture. And we have product is yellow. Over reactant is green. So I'm going to count how many yellow ones there are. 1, 2, 3, 4, 5, 6. And there are 1, 2, 3, 4, 5, 6 green ones. Okay, so there's a total of 12 molecules. At the end, I still have to have 12 molecules. Okay, and the equilibrium expression, when it's at equilibrium, this will be 3 over 1. So we need to figure out how many green molecules we need to move up to yellow so that we get this ratio. So we kind of have some factors of 3 here. Maybe we'll move 3 at a time. So what if I move 3 up here? So that should work, right? So if I move, I'm going to take 3 over here, and they're going to move to the products. This is like unconventional math. So now I have 9 on the top, 9 products, and I have 3 reactants. That will give me the right ratio of 3 over 1. Okay, thanks for checking. And then it's asking for number of reactant molecules. Oh, well, that's this bottom number. Reactants, so products on the top, reactants on the bottom, reactants on the top of my answer. That really bothers me. They should either put them side by side or not, like flip them. I'm sorry. And don't do that on the test. That's just like, I just don't know, like whoever built this question is mean. Okay, and then we still have 12 molecules, right? 3 plus 9 is 12.
So for when you're getting starting reactants and products, will they always be the same? So will it always be like 6 and 6?
No. Should we do another one? Let's do another one. No, it won't always be the same. Was our last one the same also?
Yeah.
Oh my gosh. Yeah, let's do another one. This is not the same, right?
Yeah.
Okay, so this one, we have products are gray, so products over reactants. We have 2 gray ones, and we have 2, 4, 6, 8, 10 blue ones. So we have a total of 12 molecules. And we need an equilibrium expression of, this needs to get to 3 over 1 for this to be at equilibrium. So we'll end up with the same ratio that we just saw, right? So we're going to move 7. Okay, thanks. 7 up here. So we're going to move 7 off of the reactants. They're going to turn into products. So we've got 9 over 3. That will give us this ratio again. Okay, all right. So then our reactants, we have 3 of those and 9 products. Okay. All right, so those are our 3 topics that we need to finish. What do you want to do for the rest of the time? We've got about 40 minutes. Do you just want work time and I can answer questions if you have? Are there any that you want to re-go over?
Can you go over the calories one?
Calories one, yes. And then we'll just do work time. Okay. I think it's, do you mean this one or do you mean the conversion? Interconverting. Okay, yes. Interconverting. Oops. Did I miss it? Yes, I missed it. Ah, I'm sorry. I slow at finding that. Okay, so this one, we need so this is something that I would put on my note card, even though it's in Alex. So one, oh yeah, and there's, oh, here, I will just hand you out. You have enough card? Yeah, for these tests, we just get one. The final, you get 2 sides. They do specify that it has to be handwritten. So, handwritten, yes.
What if my handwriting just happens to go off like?
As long as it's in cursive. No, has to be handwritten. Okay, so we need this conversion factor. Let me look it up to make sure I'm telling you the right one. But I will put this on my note card if I'm taking the test. Just open it enough that those Alex things pop up. Oops. So this is in the conversion factors for non-SI units. It's towards the bottom. So if you do forget this, or you can't read your handwriting, then 1 calorie is 4.184 joules. Okay. So that's something that this will be on the test, so I would make sure you have that. The other thing that's really useful to see is 1 kilocalorie is the same as 4.184 kilojoules. So I just have basically times both sides by 1,000. That's all I did. So if I do it on both sides, it's fine. Okay, so let's go back to our conversion. So this first one, we have to go from calories to kilocalories. So this one, we're just changing zeros, how many zeros there are. So we need this number, we need to divide by 1,000. So let's show that. So we have 3.60. And if you want to put a shortcut on your note card, that's fine too. I'm not going to look at your note card. So one thing you could do is if I'm going from calories to kilocalories, this is how I do it. You could write that on your note card. You could put an example if you wanted. So for 1 calorie, 1,000 calories. 1,000 calories is 1 kilocalorie. This is not a very fine marker. 1,000 calories is 1 kilocalorie. So then calories cancels and we end up with kilocalories. So I can either do this in Alex on my calculator or like on your personal calculator, or you can just look at this. This has times 10 to the 4. So this is 3 zeros. So then I would just move this down by 3. So it'd be really 3.6 times 10 to the 1. Well, 3.6 times 10 to the 1 is really 36. And this has 3 significant digits, so I'm going to keep 3. Okay. All right, and then the next one, we're going to start with that number. We have 36 kilocalories. And I need to convert between kilocalories and kilojoules, so I'm going to use this conversion factor. So 1 kilocalorie will give me 4.184 kilojoules. And so then I just multiply that through. I just need this to be a little bit bigger for my Alex calculator to pop up. There it is. Oh, it popped up. I just need to scroll. Okay. So 36, and then times by 4.184, and that gives me a decimal. I need 3 significant digits, so I'm going to round to 151, and I'm going to put a 1 at the end, or a decimal at the end. Okay, question so far?
Put a 0 at the end of that document.
Here?
Yeah.
Yes, because that would be 4 significant digits.
Even though it's 0 after.
0 after the decimal is 4. That would be 4. Yeah. Yes. If it's a 0 at the beginning, then it doesn't count. Yeah. I don't know what it would do if you put a 0 at the beginning. We don't usually do that, so I'm not sure. We could try it. Let's not try it now. Okay. The next one says an ounce of breakfast cornflakes. So we start with kilocalories. So the easiest one to do for me is to go between kilocalories and calories, because we're just moving the decimal. So this one is opposite. We have 1 kilocalorie, so we need to multiply by 1,000 calories for 1 kilocalorie. So this one, if we type in here, let's see, or we can just do the decimal. But if we do it here, 110 times 1,000, and then we can put it in scientific notation, and then it's already ready for us. So I'm going to put 1.1, but I need to put another 0 at the end, so that's 3 significant digits, times 10 to the 5. Notice these ones have the exponents. If you end up with an exponent over here, it's probably not correct. They're following this pattern of these ones have exponents, these ones are kind of small, these are kind of middle numbers. So that's one way to check. Make sure you're doing it right. Okay, and then to get from kilocalories to kilojoules, we need to multiply by our conversion factor. So if we have 110 kilocalories, we need to get that to kilojoules. Well, 1 kilocalorie is 4.184 kilojoules. Kilocalories cancels out. We'll end up with what we want, kilojoules, and that will be our answer. So let's go to our calculator. 110 times, come on, calculator. 110 times 4.184. And we don't need the exponent, so I'm going to get rid of that. So this is 460 point nothing. 460 decimal place. So now I have 3 significant digits. Okay. And then the last type would be, we have, if we're going from kilojoules to kilocalories, we need to divide by 4.184. So 314 kilojoules. So for 4.184 kilojoules, we have 1 kilocalorie. So kilojoules cancels, we'll end up with kilocalories. So then we'll find our calculator again. There it is. 314 divided by, 4.184. So that's our kilocalorie value. So notice that's kind of the smaller number, this one's kind of the medium number, and then this one has the exponent. If it has an exponent. They don't all, I don't think. Not always will you have one. I need that 0 to have 3 significant digits to match the value they gave me. And then from kilocalories to calories, I need to multiply by 1,000. So this is just easier for me to do. Oops. Here. You could probably do that in your head. I just like to do it on the calculator. 0, put a 0 at the end for 3 significant digits. 0 times 10 to the 4. Do we do it? Oops. Okay. All right. Questions? Does that help? Okay. Other ones you want to do, or are you just ready for work time? Wesley.
So I'm doing one of them, and the answer from kilojoule to kilocalories is 224.9. It's
224.9.
So it's 225.
So that's your answer?
That is 2 significant.
This is,
Digits, would it be?
that's 4.
Yeah.
Oh,
So would it be?
Yes, you would need to round to 225 for 3 significant digits, yeah. And then still put the decimal on this question, yeah. Yeah, good. Okay, I'll let you just work then. If you have questions, I can come around and answer your questions.